Okay, I guess we should get started since it's about 3:15. Well, I'd like to welcome you all here to something ISB has never before in its history done. That is, tried to mix systems thinking about science with systems thinking about art. Actually, one of my pet theses has been since the beginning that the concepts that have emerged from systems approaches to biology are really generalizable to almost any profession. And I've always been intrigued with the idea, at least some of them would be generalizable to the humanities, and in this particular occasion, to art. So what got this event started was a fortuitous opportunity. I had to meet a Chinese artist that you'll meet a little bit later in this conference, Xiao Dong Feng, who we had a really interesting interaction, which I'll say a little bit more about later. And the upshot was he said he'd like to come and visit, and it would be terrific if we could put together something on systems biology and systems art, because he himself had been thinking about global systemic views and approaches to art and things like that. So, and I managed, talking to a number of different people, to find at least 3 people who are represented here who've thought about systems aspects of art. And I think one of the interesting questions is how concordant our systems approaches to biology might be with systems approaches to art. So I thought I'd take just a minute or two and tell you a little bit about what systems biology is all about at a very, very high level. So the driving force for creating conceptually systems biology really was the complexity of both biology and disease. And in fact, what became obvious 20 or 30 years ago is that all of the classic approaches to biology really couldn't deal with the enormous sophisticated complexity of biology, and we had to create a new field that did that. And in essence, the field, in a global sense, allows one to look at biological complexity and attempt to deduce the nature of the mechanisms that create that complexity. And in systems biology, there are really 2 major approaches to do that. So one is called top-down, where generally theoretical computational people look at the complexity and they formulate models to explain all of this complexity. And I have to say that top-down approach has been remarkably unsuccessful because biology is too complicated. You just can't figure it out from, even if you're really smart, you can't figure it out from first principles. So the other approach is obviously bottom-up. And the idea here is you think about all of the elements in the system and you try and understand how they're interconnected and operate, and through that bottom-up acquiring a lot of information, you begin to deduce the properties of the system. And I'll give you a simple analogy that I think is really useful. Suppose you have a Rube Goldberg device, 14 gadgets all hooked together to let Rube Goldberg cool his soup. And suppose you wanted to take a systems approach to this device and figure out how it worked. What would you do? Well, number 1, you define all parts in the Rube Goldberg device. Number 2, you'd figure out what the parts did in isolation. Number 3, you'd figure out how the parts are connected to one another. Number 4, you'd figure out how, once you connected everything, what the dynamics was, and of course from that you try and figure out what the function is. And that's really what systems biology is. There is another aspect of systems biology that I think is really interesting to think about with regard to the humanities, and that is you have to create a proper culture and environment to successfully do systems biology. And a big part of the environment is bringing together scientists of all flavors, so you truly have a cross-disciplinary foundation of biologists and chemists and engineers and physicists and mathematicians and physicians and all. And of course, if you bring together this heterogeneous potpourri of people, you really need several things. One, you need to learn one another's language so you can communicate effectively with one another. And two, you need to learn to work together really effectively in teams. Now, I don't know if art can be done in teams or if it should be done in teams, but certainly putting together teams to attack really big problems in biology has been a central approach and feature to solving some of our hardest problems. And an example is the Human Genome Project. So with that brief introduction, I think we'll be in a really interesting position to see how each of the speakers defines their systems approaches to art and whether there is any concordance between what I've described and what they'll be describing. So what we're going to do is have our guest, Xiao Dong Feng, come and tell us about his art and his holistic vision and view of the kind of things he's going to do. And Biram Shen, his colleague, is going to serve as a translator for him. And I think he'll talk about his art and where he hopes to be able to take it. So with that, can you come up here and take the podium? And
首先感谢这个李虎德先生邀请我来参加这次会议，非常感谢。
You know, we might get another. We got another microphone. You might put that in so people.
So first, thank you very much to invite Xiao Dong here. He is very grateful for the visiting. Yeah.
我个人认为，这个艺术家和生物学家是完全是一样的。
He think scientists and arts are totally the same.
那个主要是我认为主要是什么呢？就是他的观察方式是完全一样的。
He said the scientists and arts looking at the world the same, totally the same. He said.
中国有很长的这个就是生物系统这个体系，完全和西方不一样的。那么今天我就谈一谈，就作为我的体会。
He said in China the system biology are very traditional, but totally different to the Western world. So he will talk about his feeling about the system biology.
几千年前，我们的这个道家的道士就怎么通过内视这个观察方式，发现了人体的几乎是所有的秘密。
He said thousands of years ago, the Taoism in China look at the inner world by themselves and know all the secrets there.
然后呢，这个观察方式呢，就很像这个西方的这个放大镜，只不过是我们这个中国就是内在倒过来看，自己看自己的身体而已，和西方的这个放大镜效果是一样的，通过自我观察，内在观察。
He said that we look at our inner world like the Western people look at the microbes by their self-checking, self-thinking, self-checking in the world.
我刚才给李福德先生的那个图，就是中国道家的一个内饰。
He showed you the picture. That picture is the Taoism's idea about the world, how to look at the world.
它可以完全和现代的这个生物学最先进的东西相媲美。
Okay, he thinks that picture could be compared to the modern biological science. Could be.
Do we need a picture?
Not.
那个图。
The picture he showed you there, not that picture.
送他礼物。
Only that one here. Yeah.
甚至在某些方面可能更前卫。
He believed that that picture is even better than modern science, modern biological science. He believed that.
科学家通过，比如说放大镜或者是这个倍数放大镜，但是中国人呢没有这个放大镜，古人也没有。但是他通过自己的眼睛背后的一个眼睛。
In ancient China, we have no modern equipment, but the toys today have their solar eyes somewhere here to check the world.
我很荣幸的说，我自己曾经体会到。
He said he once experienced that experience. Toys experience. He can see the world by the solar eyes somewhere here. He could feel that. He experienced it once.
待会儿我展示的一批就是最新的作品，就展示了我内视所看到的一个世界，然后通过现实的东西结合画出来的这么一个系列的作品。
He will show his patterns, his feeling about the world by the similar ideas, like the similar ideas from Taoism. He see the world and show with the painting. He will show his painting.
我现在因为只有10分钟时间，所以呢，我就想就是说给大家看看作品，希望能给所有的这些科学家们一点启示。
He said only 10 minutes, so time is limited. He wished to show his paintings to show you the greatest scientists. He wished can give you some idea.
毕竟东西方的这个科学研究是完全不同。
So the Western and Eastern are totally different some way. Okay.
还有是说这个音乐作品是。
He will show his paintings, also the play of the music also by himself. He also play music. Yeah. Okay.